I'm Brian Hughes. I work as a Soil and Land Management Officer for PIRSA, based out of the Newry office. Today I'm just giving a brief rundown of the geology of the Barossa ranges and valley, and I suppose how they align to the soil pits that were done as a recent big field day. Just starting off, I suppose, and I'll start off at the beginning perhaps. The Mount Lofty Ranges, or the Northern Mount Lofty Ranges and Barossa Ranges, really started as an old seabed with various sediments that were being laid down around about 600 million years ago, and you had a range of different types of things that were being laid down. There might be sandy layers, clay layers, shelly layers, and silty layers, and these were all laid down at the bottom of the seabed around about 300 million years. I suppose some of these areas started getting a lot of pressure on the sides, and you'll actually see that eventually, I suppose, these layers were pushed upwards, compressed to some stage, heated and cooled, and various pressure undertaken across those areas. As the layers sort of folded, they began forming the Mount Lofty Ranges uplands, and I suppose through that process there was a lot of metamorphism of the actual layers. So, the sand became sort of sandstone or quartzite. The clay became more shaly type rocks. The silt became siltstone, and the shells in some cases became limestone layers or marble, which is the sort of rocks that we see today. So the Mount Lofty Ranges block really was still moving upwards, and I suppose on the sides of that, the Murray-Darling Basin and I suppose the St Vincent's Gulf were moving downwards. In some areas, the hilly surface areas also eroded to a plateau and became deeply weathered areas, and I suppose those little patches of this occur, and you get the ironstone soils, particularly evident around Mount Crawford in the northern Mount Lofty Ranges, but places like Para, they're much more widespread. During the tertiary period, which is then, I suppose, we had these laterite caps formed on these areas, and some erosion and gulges in those as well. Again, during the tertiary period, I suppose the Barossa Valley has become filled with various sediments, including quite a few sandy sediments, and through to, at times when the sea level was much higher, you had sort of clays and silts being deposited there, and over time, I suppose you ended up with what you see there today. A lot of sand. You've got areas that have got sort of high marsh clay in them, and I suppose depending on the height of the sea level, and I suppose what you see in the Barossa today is you're really seeing patches with some dominated by the clay soils around Tanunda, for example, other old alluvian areas around Newry, which are a bit sandier or a bit different to those as well, and the evidence of the soils and the variation of the soils sort of from those tertiary sediments that have infilled. Also on the western side of the valley as well, there are some other hills that have formed as well, and I suppose the Canunga site that we looked at, I suppose the alluvium that's ended up there is probably from those hills as well. Now, much of the Barossa Ranges is very much in what they call the Kanmantoo block, I suppose, and while there's a lot of sandstones and quartzites and that, you also do find little bands of granite, and they were sort of formed through igneous conditions under the ground. Really, there was no surface expression of that, but then exposed as the uplift occurred. Now, when you start looking at and I suppose this is probably, if you look at this now, so you can actually look through on the eastern Kanmantoo metasediments that were common around the Barossa Ranges, little bands of granite, and then as you go to the western and the more central part of the hills, bits of sandstone and silt and shale, down which you do find down the bottom end of the Barossa Valley. And on the very western side around Angaston, we see the limestone or the marble type areas as well. So when looking at the soils that we looked at through the Barossa, the big field day, there were really, I suppose, three soils there that were formed directly in the rock. If you look at Keynes's soil at Cainton Way, from about 60 centimetres, you can actually see some of that meta sandstone in the actual soil pit, and the soil's actually formed over the top of that forming sort of a sandy loam surface over clay, then over weathered rock. Quite similar in some ways in the geology is the site at Evans. Again, about 70 centimetres deep, you'll see the weathered parent material, weathered sort of metasandstone and some little bands of schist amongst that and bits of mica. But the soil again has formed over the top of that rock as it's weathered over millions of years. When we move on to the side of Coffs, the soil is very much formed in what we call the Angaston marble. So it's in one of these limestone bands that was, a long time ago was possibly a band of shells under the ocean. The lime, we actually analysed that lime, and it was actually quite a pure amount of lime in that, and we had quite a reasonable neutralising value as well. So yeah, the local term for that is the Angaston marble deposit. Now further to the west, I suppose the Kleinig site was a little bit different, because that was certainly formed in alluvium. There was no evidence of any parent rock in that, and the alluvium was from these western ranges of the Barossa Valley, which are a little bit different. They're more sort of tillites and slates, and again some metasandstone in that as well, but it's basically formed from the infill of those rocks going into that valley. And you've ended up with a deep alluvial soil there, with again sandy loam over clay, but over deeper clays and sands as you go down deeper through the sediments. In summary, we've seen in the Barossa ranges a lot of the upper slope soils that are formed very much in the parent material in the rock, and the rock very much influences what the soil type ends up being. And as you go into the Barossa Valley and I suppose the smaller valleys and drainage lines within the hills, you see that the alluvial material is what's formed the soils into much deeper profiles. And in some ways, I suppose, in the Mount Lofty ranges generally, we'd say that the parent material has had a large influence on the soil types, and we don't necessarily see that across the rest of South Australia, where there's a lot more wind blown and water material, I suppose, generally involved in soil processes. These have covered off some of the soils, but certainly there is a range of soil types, and there's, again, very much influenced by the rock underneath up in the hills, and even in the alluvial areas you can see areas that's quite deep sand, because that's what was deposited there through that process, through to sort of loamier and clayier sort of alluviums. The ages of these soils are quite different. Certainly the alluvial soils are a lot younger, while the soils that are formed in the rock, the basement rock on those are sort of hundreds of millions of years old almost. so the soil's taken a long time to form on those, and probably reflects a little bit how slow our soil forming processes are.